Good morning again from the Kennedy Space Center in Florida. I'm Stephen Clark, editor of Spaceflight Now, and welcome to our live coverage of the Artemis 1 launch countdown. Right now, all preparations are on schedule for the start of cryogenic tanking of the Space Launch System moon rocket on pad 39B here at Kennedy. Those preparations will begin at about 30 minutes, around 6 a.m. Eastern, 10 a.m. UTC, with the chill down of the liquid oxygen transfer line leading from the ground storage tank to the mobile launch platform and ultimately into the core stage of the SLS moon rocket. Following that chill down for liquid oxygen and liquid hydrogen, those transfer lines, those propellants will begin loading into the rocket to begin fueling up for today's launch attempt. The 2-hour launch window opens at 2:17 p.m. Eastern Time. That's 18:17 UTC. There's a 90% chance of good weather for tanking this morning. The cryogenic loading was delayed nearly an hour on the previous Artemis 1 launch attempt back on Monday. Right now, there's no imminent threat of any lightning in the area that could prevent an on-time start to tanking this morning. The weather forecast for launch this afternoon is fairly favorable. There's a 60% chance of acceptable conditions for liftoff of the more than 30-story tall Artemis 1 moon rocket at the opening of the window. That's at 2:17 p.m. Eastern, 18:17 UTC. Those conditions are expected to improve throughout the 2-hour window, with the chance of thunderstorms in the area decreasing. The odds of launch, or the odds of acceptable weather for launch, increase to an 80% chance of acceptable conditions at the close of the 2-hour window at 4:17 p.m. Eastern, 2017 UTC. The main weather concerns that the weather team and the Artemis 1 launch team will be monitoring this afternoon will be with the threat of lightning. They'll be watching for cumulus clouds associated with rain showers and thunderstorms that may have a threat of lightning in them. They also will be monitoring measurements from field mills around the Space Center to collect data on the electrical charge in the atmosphere. If either of those parameters or a number of other weather criteria aren't go, the launch will not be able to proceed today. But officials are optimistic that while there may be thunderstorms in the area, there may be times when the weather is no-go during that 2-hour window. There will be at least a shot during the 2-hour window of clear weather, clear skies, at least clear enough to allow the Space Launch System to get off the ground today. The countdown clock is at T-minus 6 hours, 40 minutes, and holding. The countdown entered this hole nearly 1 hour ago, around 4:37 a.m. Eastern Time. This is a planned stop in the countdown clock that will run 2.5 hours. And if all goes according to plan, the countdown clock will resume ticking at 7:07 a.m. Eastern Time. This is the second launch attempt for the Artemis 1 mission following a scrub back on Monday. That scrub was ultimately caused by data that the launch team was analyzing that showed that one of the 4 core stage engines on the Space Launch System was not being properly cooled or thermally conditioned. That engine needs to get down near minus 420 degrees Fahrenheit, which is the temperature of the liquid hydrogen that will flow into those engines during flight. And the data showed it wasn't quite reaching that cryogenic temperature during a process known as chill down. But further review of data by NASA's launch team and the Space Launch System engineers showed or drove them to conclude that the data they were looking at Monday that showed the engine was not at the correct temperature was actually being collected by a bad sensor. The data was erroneous, and NASA plans to verify the temperature of those engines through other means, through other data measurements, not using that bad sensor. during today's operation. That chill down is expected to begin around 8 a.m. Eastern. That's 12 o'clock UTC today. A couple of hours into the tanking process this morning. That will involve a bleed flow of liquid hydrogen, which again is chilled to minus 423 degrees Fahrenheit, through the engine compartment on the bottom of the core stage. And the engineers will be monitoring data, obviously not from that bad sensor, but from other measurements to verify the engines do reach the proper temperature. So we heard a go from the mission management team a few minutes ago. This is the team chaired by Artemis 1 mission manager Mike Serafin. And the next step we expect to hear confirmation of is the go for tanking from Launch Director Charlie Blackwell Thompson, who is in the firing room at the Launch Control Center here at Kennedy. And once she gives her go, the launch team will begin those tanking operations in earnest with the chill down of the transfer lines for liquid oxygen. And we've just heard confirmation from NASA that the launch director, Charlie Blackwell Thompson, here at the Kennedy Space Center, has given her go to begin propellant loading operations this morning for the Space Launch System. So we've heard a go from the mission management team a few minutes ago, and then just now a go from Launch Director Charlie Blackwell Thompson. So preparations are on track for an on-time start to propellant loading this morning out at Launch Complex 39B. This view you're seeing now comes from the Kennedy Space Center press site, about 3.5 miles from the pad. You can see the moon rocket perched out on pad 39B, 322 feet tall, or 98 meters in height, and the countdown clock here at the press site continuing to hold as planned at T-minus 6 hours and 40 minutes. This is a 2.5-hour hold. We're now a little more than an hour into that hold. The clock will pick up shortly after 7 a.m. Eastern. The latest update from NASA confirms the start of chill down of the liquid oxygen chill down line transfer lines. This involves flowing small amounts of this cryogenic oxidizer. So, just the update from NASA, the liquid oxygen chill down of the liquid oxygen transfer lines at Launch Complex 39B is now underway. This involves flowing small amounts of liquid oxygen through the lines that lead from the storage tank at the spherical reservoir that contains the liquid oxygen at the pad through the lines leading to the mobile launch platform. This conditions the various hardware needed to flow the liquid oxygen into the rocket for the actual beginning of loading of the core stage, which is expected to begin in around an hour, maybe a little under an hour from now. The liquid oxygen is stored in a tank on the northwest perimeter of pad 39B. Liquid hydrogen is in a tank on the northeast side of the pad with transfer lines leading into the rocket from both ground storage spheres. But the first operation this morning, per the timeline, is to begin the chill down for liquid oxygen transfer lines leading from that storage tank up the deck to the mobile launch platform and then into the rocket. And that will precede the start of actual loading of 195,000 gallons of liquid oxygen into the core stage this morning. We're now showing views from NASA engineering cameras at pad 39B. Here you can see the bottom of the core stage with the 4 RS-25 main engines. You can see 2 of them easily there, mounted to the bottom of that core stage. That core stage is about 27.5 feet, 8.4 meters in diameter. It's the same diameter of the space shuttle external tank. A lot of the designs and components for the Space Launch System are derived from the shuttle program. The RS-25 engines in the bottom of the first stage are actually leftovers from the space shuttle. NASA and Aerojet Rocketdyne, which built the RS-25 engines, had 16 of those engines in a flight-ready or near flight-ready condition at the end of the shuttle program. That's enough for 4 Space Launch System flights. They have plans, NASA and Aerojet Rocketdyne have a contract to begin production of additional RS-25 engines for SLS flights beyond Artemis 4. Again, this is the Artemis 1 test flight. It's the unpiloted test flight of the Space Launch System and Orion spacecraft around the moon to pave the way for future crew flights on the SLS and Orion vehicles. If everything goes well on this flight, NASA plans to put 4 astronauts on the next SLS Orion mission, Artemis 2, currently scheduled for the mid-2024 timeframe. That will send an Orion spacecraft on a loop, a free return trajectory around the far side of the moon and then back to Earth. And then NASA plans for the Artemis 3 mission to actually involve a landing on the moon using a commercial lander developed by SpaceX based on SpaceX's Starship rocket design. That will be the lander, and the Space Launch System and the Orion spacecraft that you see here, a very similar vehicle to what you see here, will be used for the transportation of the crew from Earth to the vicinity of the moon, where they'll link up with the Starship landing system, which will take them to the surface of the moon near the South Pole region. The current plan is for a crew of 2 to make that trip to the moon's surface on Artemis 3. 2 astronauts would remain behind in the Orion spacecraft. And then the Starship would bring the crew back to the Orion spacecraft for a docking. And then the Orion would bring all 4 crew members back to Earth. That's the current architecture for the Artemis 3 mission, which is the first crew landing as part of NASA's Artemis moon program. But first, this Artemis 1 test flight that we hope to see launch today from the Kennedy Space Center will help engineers verify the various elements of the Space Launch System in an integrated test. And then Artemis 2 will be the crew flight test, essentially, for this system, leading up to that moon landing attempt on Artemis 3 later this decade. This view comes from the top of the mobile launch tower, looking down on the Orion spacecraft. At the very top of the screen, you can see part of the Orion's launch abort system. That's the needle-shaped pointy feature at the top of the Orion spacecraft. For this mission, the launch abort system is only partially active. The launch abort motor, which would be used on a crew flight to actually pull the spacecraft and its occupants away from a failing rocket during launch, is not active. It's inert for this mission. However, that structure, that launch abort system, still needs to get off the rocket, even though it's an uncrewed flight, for the Artemis 1 mission to proceed out to the moon. So the jettison motor, it's a solid fuel motor on that launch abort system, is active and will fire a little more than 3 minutes into the flight to jettison that tower from the Orion spacecraft and expose the crew module to the space environment for the first time. The Orion is enclosed in that aeroshell for the flight through the atmosphere. There are also panels, 3 panels, attached to the outer perimeter, the circumference of the service module below the crew module of the Orion spacecraft. Those will be jettisoned also about 3 minutes and 11 seconds into the flight. Those panels, one of those panels is the section that actually has the NASA and European Space Agency logo here that you can see. The European Space Agency oversees and funds the development and production of Orion service modules as part of an international agreement with NASA. NASA is responsible for the Orion crew module and the Space Launch System. A few minutes ago, we also heard confirmation that liquid hydrogen chill down for the transfer lines at Pad 39B is underway. So liquid oxygen and liquid hydrogen chill down of the transfer lines on the ground facility at Pad 39B are underway at this hour. One of the changes to the countdown this morning was moving up the time of liquid hydrogen chill down. That accommodates a change later in the countdown to move forward the chill down, or the start of the chill down process for the RS-25 engines through a bleed line. This has been a continuing point of concern for NASA's Artemis launch team. Back in June, there was a leak and a quick disconnect in the bleed system that feeds liquid hydrogen into the engines for thermally conditioning those engines for ignition. This is not the line that actually flows fuel into the engines for when those engines light. It's a preconditioning of those engines during the countdown. That leak was repaired after the rocket returned to the vehicle assembly building. And during the first launch attempt, during the countdown Monday, engineers saw some data that engine number 3, one of the 4 engines on the bottom of the core stage, was not being properly cooled. It wasn't reaching the expected cryogenic temperature, more than 400 degrees below 0 Fahrenheit. Engineers concluded that data that showed the temperature was not as cold as expected. It was actually erroneous. The data came from a bad sensor, according to NASA. The launch team has other means of verifying the temperatures inside those engines, and will actually essentially overlook or ignore the data from this one bad sensor and confirm the temperature through other sensors and other measurements that the temperature in those engines have reached cold enough levels for a safe startup of those engines at ignition. Those engines will light at T-minus 6 seconds. And if those engines are passing a health check, if everything looks good, the flight computer on the Space Launch System will give the command at T0 for ignition of the 2 solid rocket boosters. You can see this camera view panning up and down the Orion spacecraft. We saw the launch abort system just a couple seconds ago. Here's the crew module and the service module inside that aeroshell. And this is now the area of the upper stage, the interim cryogenic propulsion stage. And this is the launch vehicle stage adapter, a tapered cone-shaped structure that expands to the diameter from the smaller width of the upper stage to the nearly 28-foot diameter of the core stage. The core stage and the launch vehicle stage adapter are covered in this orange foam insulation. This foam serves a couple of purposes. One is to prevent excessive buildup of ice on the outer skin of the core stage as the cryogenic super cold propellants are loaded into it. And it also helps insulate the tanks to keep those propellants cold and to minimize boil off during the countdown. NASA has just confirmed the start of slow fill for liquid hydrogen into the core stage of the Space Launch System. This is the first tank to be loaded this morning. Again, as I was saying a few minutes ago, the timeline for this morning's countdown has changed a bit from the timeline that NASA followed on Monday, and also the timeline that NASA followed during countdown rehearsals earlier in the year. On those previous countdowns, we saw NASA load liquid oxygen into the core stage first. This morning, liquid hydrogen is going in first. This is to allow NASA to actually bring forward the start of the kickstart bleed on the RS-25 main engines, which you're seeing here on the bottom of the core stage, right in the center, bottom center of this view. This kickstart bleed involves the flowing small amounts of liquid hydrogen through those engines, through lines into the engine compartment, into the engines themselves, to condition them and bring them down to cryogenic temperatures. The liquid hydrogen is stored at minus 423 degrees Fahrenheit. So flowing that super cold fluid through the engines will bring down the temperature of those engine components down to similar temperatures, similar levels, more than 400 degrees below 0 Fahrenheit. Those engines need to be at that temperature to sustain and weather the shock of the flow of cryogenic fluid, cryogenic propellant, the rapid flow of that fluid when the engines actually begin their ignition or startup sequence at T-minus 6 seconds. So in order to bring forward the kickstart bleed to allow more time for those engines to chill down, NASA needed to actually move forward the start of liquid hydrogen loading, which is what we're seeing now. Liquid oxygen remains in chill down. The transfer lines leading from the liquid oxygen storage tank to the launch platform are being conditioned themselves at this time before we expect to hear the actual start of slow fill of the liquid oxygen tank on the core stage. So again, liquid hydrogen is in slow fill on the core stage. That will transition to fast fill a little bit later in the countdown. Those lines that load cryogenic propellants into the core stage lead through what are called the tail service mast umbilicals. Those are at the bottom of the core stage, actually attached to the launch platform deck itself. There's one for liquid oxygen, one for liquid hydrogen. So just to recap where NASA is in the countdown, liquid hydrogen loading is underway on the core stage. Liquid oxygen loading will get underway shortly. And then later in the countdown, still a couple of hours away, we'll see the upper stage of the Space Launch System moon rocket begin to receive its supply of cryogenic propellants. Liftoff remains scheduled for this afternoon during a 2-hour window, opening at 2:17 p.m. Eastern Time, 1817 UTC. This up-close view of the RS-25 engines on the bottom of the core stage. You can see some vapors venting through the engine there as the propellant loading process progresses this morning. The latest update from NASA indicated that the liquid oxygen system was in chill down, and the liquid hydrogen system is now in slow fill mode, actually flowing cryogenic fuel into the core stage. NASA says that the liquid oxygen system is now in main propulsion system chill down. NASA reports they're now in a stop flow status on both liquid oxygen and liquid hydrogen. You can see in this view that flow of vapor we saw from those main engines and the main propulsion system chill down has ended. We're awaiting word on the reason for this stop flow. NASA's launch commentator mentioned a couple of issues. NASA reports there was a stop flow in the liquid hydrogen into the core stage briefly due to an overpressure alarm. But NASA's launch commentator Daryl Nail reports that the flow has resumed after that brief stop of flow of liquid hydrogen into the core stage. There's also an issue with a liquid oxygen system that's currently being studied by the launch team, but the team hopes to overcome that and resume liquid oxygen operations shortly. We'll stand by for a further update from NASA. You're looking at a live view of Launch Complex 39B this morning, where NASA's Space Launch System is awaiting an opportunity to fly this afternoon if everything goes according to plan throughout this marathon countdown. The launch window opens at 2:17 p.m. Eastern Time, 18:17 UTC. The window extends for 2 hours this afternoon. If the launch does not get off the ground today, depending on the reason for the scrub, if the team can turn around and get in a position for another countdown, the next launch opportunity would be Monday. Monday's launch window would open at 5:12 p.m. Eastern Time, 21:12 UTC, but there's hope among the launch team today to get this Artemis 1 mission off the planet at 2:17 p.m. to 4:17 p.m. Eastern, 18:17 to 20:17 UTC. There is a 60% chance of good weather at the opening of the window. The main risk associated with the weather will be lightning and thunderstorms in the area, but the weather conditions are forecast to improve by the end of the window with an 80% probability of acceptable weather then. The countdown clock that you're seeing on the upper right is at T-minus 6 hours, 40 minutes, and holding. This is a built-in hold that is expected to end in roughly 20 minutes at 7:07 a.m. Eastern Time. We expect to see that clock, which you see here at the Kennedy Space Center press site, to resume in about 20 minutes at T-minus 6 hours and 40 minutes. And at that point, the clock will tick down to the next and final built-in hold at T-minus 10 minutes. So you'll see the clock stop again at 10 minutes for a half hour. And during that time, the launch director and other members of the launch team will be polled for go or no-go status before entering the terminal countdown at T-minus 10. NASA reports that the liquid oxygen system, that issue that they discussed a couple of minutes ago, apparently has been resolved. The pump that is actually driving the flow of liquid oxygen from the storage tank to the launch platform and into the rocket has been repressurized. NASA believes that the issue with liquid oxygen might have been caused by the tank at pad 39B being at a very high level. Those tanks, liquid oxygen and liquid hydrogen, were topped off following the attempt that was scrubbed on Monday. That sets up for these next two launch opportunities for Artemis 1 today and Monday. So after apparently overcoming that little hiccup with the liquid oxygen system a few minutes ago, NASA's launch team confirms that the liquid oxygen tank on the core stage is in slow fill mode. So both propellants now in slow fill at last report into the core stage, liquid oxygen and liquid hydrogen. About 537,000 gallons of liquid hydrogen and about 196,000 gallons of liquid oxygen will be loaded into the core stage during this countdown. That process will take about 2 to 3 hours. And after a period in slow fill, those loading operations will transition to fast fill mode to more rapidly flow propellants into the core stage. NASA reports that these issues with the overpressure alarm on the liquid hydrogen system and the brief stop of flow of liquid oxygen during the chill down are expected to have minimal impact on the timeline for today's launch attempt. You can see here pad 39B in the background is the eastern horizon, where we're seeing some of the first light at dawn here on Florida Space Coast. You can see some of the clouds offshore associated with some thunderstorms out over the Atlantic Ocean. Those are not an immediate threat to the area around the launch site. But later in the day, there is a chance for some of those showers to either move onshore or additional cells to develop and move inland. And when those develop and move inland, they will or could move over the launch site area here at the Kennedy Space Center. And that's what the weather team will be watching this afternoon during the 2-hour launch window. Again, the countdown clock that you see in the upper right is at T-minus 6 hours, 40 minutes and holding. That clock should resume in 11 minutes. NASA confirms that the slow fill of liquid hydrogen has resumed. We reported that a few minutes ago based on a NASA statement from NASA's commentator a little earlier in the countdown that the flow had resumed after a brief stop flow for liquid hydrogen, but that may have been a little premature. So NASA now has reconfirmed the start of slow fill, resumption of slow fill of liquid hydrogen into the core stage. The stop flow of liquid hydrogen was caused by an overpressure alarm. According to NASA, near the intertank umbilical area, which is about halfway up the Space Launch System between the liquid hydrogen and liquid oxygen tank on the core stage. So both propellants are now in slow fill on the core stage of the Artemis 1 moon rocket at Pat 39B. This view is showing those RS-25 engines with the flow of vapor coming out of them. And the Artemis 1 countdown clock has resumed on schedule. It's T-minus 6 hours, 40 minutes, and counting. This view comes from the Kennedy Space Center press site, about 3.5 miles from the Space Launch System on Pad 39B. You can see some of the news media have staked out their positions with tripods on the press site lawn for this afternoon's launch opportunity. NASA has also just confirmed the liquid oxygen on the core stage is now in fast fill mode. This ramps up the pump speed to drive this liquid oxygen into the core stage. About 196,000 gallons of liquid oxygen will be loaded into the core stage. And last update from the launch team. Liquid hydrogen on the core stage remained in slow fill mode. It will transition to fast fill shortly. And we'll await confirmation of that transition to fast fill from NASA's Artemis 1 launch team here at the Kennedy Space Center. This view from one of the engineering cameras at pad 39B shows the tail service mast. Well, now it's panning away from that, but you could see the tail service mast umbilical connections there for a moment, showing the connection between the mobile launch platform and the core stage. That's where the propellants are actually flowing into the vehicle at this time. NASA has updated us again on the status of the countdown. This morning, the liquid hydrogen is again in stop flow due to a leak that was detected in an engine cavity on the Space Launch System core stage. The launch team believes the leak is in a quick disconnect, and the plan is to actually stop the flow. The flow has stopped, but the plan is to continue this stop flow status on the liquid hydrogen to allow that quick disconnect to warm up from its cryogenic temperatures a little bit, and then they will resume flow with the super cold hydrogen through that quick disconnect, and in hopes that the that connector is able to reseat itself when it's hit with that flow of liquid hydrogen. That cryogenic fluid, when it's in contact with components on the rocket, can cause those components to change shape, contract a little bit when they're exposed to that cold temperature. So that's the plan to troubleshoot this quick disconnect leak in an engine cavity on the Space Launch System core stage. So this is expected to be about a 30-minute delay in the liquid hydrogen loading this morning, assuming that the leak does get resolved with this troubleshooting plan. In the meantime, the loading of liquid oxygen is being actually throttled back a bit to ensure that there's not too much liquid oxygen loaded into the core stage without the liquid hydrogen being loaded into the core stage. The liquid oxygen tank actually sits above the liquid hydrogen tank, and there's a constraint called the aft strut constraint. It's a structural constraint that says that essentially there can't be more than 50% of a load of liquid oxygen into that LOX tank on the core stage without liquid hydrogen in the core stage as well. This quick disconnect leak in the engine cavity is not associated with the tail service mass area, according to NASA's launch commentator. So it's not in the area where they've seen a hydrogen leak before during the previous launch attempt on Monday and during the countdown rehearsals earlier this year. This appears to be a leak in a new area. The opening of today's Artemis 1 launch window now is less than 7 hours away. To recap where the launch countdown currently stands, the flow of liquid hydrogen into the Space Launch System's core stage has been stopped temporarily due to the detection of a hydrogen leak in the engine cavity on the core stage. Here you see 2 of the 4 RS-25 engines on the bottom of the Space Launch System core stage. So with that leak detected in a quick disconnect fitting, the launch team has stopped the flow of liquid hydrogen. They're going to allow that fitting, that quick disconnect area, to actually warm up from cryogenic temperatures closer to ambient temperature. And that basically allows the shape of the quick disconnect to change as the temperatures change. And then they'll flow the hydrogen through that area again. The hydrogen is chilled to minus 423 degrees Fahrenheit. So when it's when that flow resumes with that super cold fluid, NASA's launch team hopes that the quick disconnect fitting reseats itself, the seal reseats itself as it contracts. This has been demonstrated to be feasible during previous troubleshooting of similar hydrogen leaks. So the team hopes this will work to resolve today's leak. This leak is not in the area that has exhibited hydrogen leaks during previous Space Launch System countdowns. That's in the tail service mast area, which you see here to the right of the core stage. That's where the liquid propellants flow into the rocket from the launch platform during the fueling process. NASA says the leak that they found this morning is not in that area, it's in the engine cavity. While we wait for an update on the countdown and for this troubleshooting plan to go forward for this hydrogen leak, I want to thank you for joining our coverage this morning. We're reporting live from the Kennedy Space Center in Florida. If you haven't already, please like our stream. That really helps us gain an audience and expand the reach of our launch coverage. So if you haven't done it yet, please like this stream, like our coverage here on our YouTube channel. If you want to support our coverage, you can also join our YouTube channel. We have different membership tiers available for you to choose from, and depending which level you do select, you can gain access to exclusive video features available to members only. So if you want access to that coverage, that bonus coverage, please consider joining our YouTube channel, and we would appreciate your support in that area. Also, if you haven't done this yet, you can subscribe to our YouTube channel as well, so you can get alerts and a heads up anytime we're beginning a live stream like we're doing this morning. While NASA's launch team continues to discuss and troubleshoot this hydrogen leak in the engine section of the core stage, liquid oxygen loading on the core stage is continuing, albeit at a bit of a throttled back rate, slower rate of loading of liquid oxygen. Liquid oxygen is currently at 15% full on the core stage. The liquid oxygen tank is actually sitting above the hydrogen tank on the SLS core stage, and there is a constraint called the aft strut constraint that limits the load of liquid oxygen on the core stage to no more than 50% until the liquid hydrogen level reaches a certain point on the core stage. This is to ensure proper structural loads and thermal balancing on the core stage as these propellants load into the vehicle. Liquid oxygen is loading at a temperature of nearly minus 300 degrees Fahrenheit, about minus 294 Fahrenheit. The liquid hydrogen is at minus 423 Fahrenheit. Continuing to wait on a update from NASA on the troubleshooting plan and status after the team detected this hydrogen leak in the engine section or engine cavity area of the Space Launch System core stage. Latest we've heard from NASA's launch team over in Firing Room 1 at the Launch Control Center is that the liquid hydrogen was in stop flow. They stopped loading liquid hydrogen into the core stage when they detected this leak. And the liquid oxygen load onto the core stage is continuing, albeit at a slower rate intentionally, so as not to essentially overload the liquid oxygen tank, which sits above the hydrogen tank, without the hydrogen reaching a certain level on the rocket. The launch window now opens in a little less than 6 hours and 40 minutes, 6 hours and 38 minutes until the launch window opens. The countdown clock you're seeing on the upper right is the T-minus clock. That's the official countdown clock coming from the firing room. T-minus 6 hours, 8 minutes and counting. There is a planned 30-minute hold at T-minus 10 minutes. So there's a 30-minute discrepancy between the time on the official NASA countdown clock, which is what we're showing, and the actual time until the opening of the launch window. Assuming this leak is resolved through the troubleshooting steps that are currently being discussed by the team, it's not clear whether this delay will impact whether the Space Launch System can get off the ground at the opening of the window today. There is a little bit of margin in the timeline, although the stop flow of liquid hydrogen is now been stopped for nearly a half hour, a little more than 20 minutes since that stop flow was reported. So the propellant loading, the fueling of hydrogen into the core stage is now running at least 20 minutes behind schedule. NASA's launch team is preparing to implement this troubleshooting step to hopefully resolve this this leak in the liquid hydrogen loading system. A clarification that we just got from NASA's launch team. NASA's launch commentator said earlier that the leak was in an engine cavity or in the engine section area of the core stage. The launch team now says the leak is near the plate where the liquid hydrogen lines that flow into the core stage come from the mobile launch platform onto the rocket itself. And this is an area known as the tail service mast umbilical. There's 2 umbilicals with a set of lines for liquid oxygen and liquid hydrogen. And the quick disconnect that is apparently leaking is the 8-inch line that actually flows liquid hydrogen from the ground storage tanks through the platform into the core stage. That's the latest update from NASA's launch team in Firing Room 1. So this leak is in the same area that NASA has encountered leaks in during previous Space Launch System countdowns. It's not yet 100% clear whether this leak is in the same line, although it is in the tail service mast umbilical area. while NASA's launch team continues to discuss and troubleshoot the leak in the liquid hydrogen loading system at the base of the core stage near the connection with the mobile launch platform. Liquid oxygen loading onto the core stage is now at 26%, and loading is continuing of liquid oxygen onto the core stage, albeit at a slow rate to ensure that the liquid oxygen tank is not overloaded before the resumption of liquid hydrogen flow. The core stage holds about 733,000 gallons of cryogenic propellants. Most of that volume is liquid hydrogen. And the 4 RS-25 main engines on the bottom of the core stage will consume the liquid oxygen and liquid hydrogen in flight. Each of those engines are reused from the space shuttle program. And those 4 engines will consume together about 1,500 gallons of propellant every second while they're firing during the core stage's 8-minute burn to begin the Artemis 1 mission to the moon. NASA is continuing to evaluate and troubleshoot this hydrogen leak that's been detected in a cavity essentially between the plates that connect the tail service mast umbilical to the bottom of the core stage. We've circled the tail service mast umbilical here in this live view of the launch pad, pad 39B. This is the area that feeds liquid oxygen and liquid hydrogen rather into the core stage. There are plates on the ground side and the flight side, on the launch platform side and the core stage side, and there was a detection of gaseous hydrogen in the cavity in between those plates, according to NASA's launch commentator. Here you see an up-close view of the tail service mast connections. Again, one of these supplies liquid hydrogen, one of these supplies liquid oxygen. The liquid hydrogen flows directly into the rocket, into the hydrogen tank, which is at the bottom of the core stage. And liquid oxygen actually flows up a feed line up to the top of the core stage for loading into the oxygen tank. On the right side here is the liquid hydrogen tail service mast umbilical. That's where this leak is believed to be originating in a quick disconnect fitting. It's an 8-inch line, according to NASA, that is leaking. Left side here is the liquid oxygen umbilical. NASA's launch team reports that the flow of liquid hydrogen has resumed into the core stage at a very slow rate. The team is actually manually controlling the flow rate of liquid hydrogen into the core stage and monitoring sensors that measure concentrations of gaseous hydrogen around that tail service mast umbilical near the plate that connects up with the engine section of the core stage. Monitoring those sensors to ensure that there's no leak. NASA teams are hopeful that this troubleshooting, which allowed this leaky 8-inch QD, or quick disconnect fitting, to warm up before resuming the flow of super cold liquid hydrogen, has resolved the leak, although they're watching that closely at this point for any signs of further leak in that system. The countdown clock that you're seeing on the upper right is just past the T-minus 5-hour, 32-minute point. The clock is heading toward a built-in hold at T-minus 10 minutes. That hold will last a half hour if the countdown goes according to the timeline. This view from the top of the mobile launcher tower out at Pad 39B is looking down on the Space Launch System. You can see that array of umbilical lines and umbilical arms connecting to different parts of the Space Launch System and the Orion spacecraft as this vehicle awaits a launch opportunity this afternoon on the Artemis 1 moon mission. This is a test flight of the Space Launch System. This is the first flight of NASA's new moon rocket. It stands 322 feet tall, 98 meters in height. These swing arms that you're looking at now will all retract at T0 as the rocket begins its climb away from the Kennedy Space Center. The arm closest to the camera view is actually the umbilical connecting to the Orion service module. Below that is an umbilical connecting to the ICPS. That's the interim cryogenic propulsion stage, the upper stage of this powerful launch vehicle. And then below that, to the right, near the right-hand solid rocket booster, if you look closely, you can see the intertank umbilical that connects to the top of the core stage. Liquid oxygen now is at 39% full, continues loading into the core stage. Liquid hydrogen is now flowing into the core stage, as I mentioned a bit ago, at a very slow rate, manually controlled by the launch team. That liquid hydrogen tank is now at 4% full. Now less than 6 hours remaining until the opening of today's Artemis 1 launch window. The 2-hour window opens at 2:17 p.m. Eastern Time, 18:17 UTC, and extends until 4:17 p.m. Eastern. As liquid oxygen loading continues onto the Space Launch System core stage, we're now seeing the gaseous oxygen vent active near the top of the core stage. That tank is now more than 40% full, and loading is continuing there in fast fill mode. Meanwhile, manual loading at a very slow flow rate of the liquid hydrogen tank continues. This modified procedure, not running on the software scripts, but under the manual control of the launch team, is to troubleshoot and attempt to overcome and resolve this hydrogen leak that was detected down near the bottom of the core stage, where it connects to the tail service mast umbilical in that area, at the very bottom of the core stage near the engine section. The countdown is running behind schedule, at least in terms of liquid hydrogen operations. The fast fill of liquid hydrogen was to begin nearly 30 minutes ago, and that has not yet begun at this point. You're watching now a view from one of the engineering cameras out at Pad 39B, panning down the very top of the Orion spacecraft, the launch abort system area. This is at the very top of the 322-foot tall, or 98-meter tall, Space Launch System moon rocket. That launch abort system was mated to the Orion spacecraft. It actually includes this aeroshell that's around the crew module of Orion. The mating between the crew module and the launch abort system occurred last year at the at a payload processing facility here at the Kennedy Space Center. Then the Orion spacecraft was transferred last October, nearly 11 months ago, more than 10 months ago, to the vehicle assembly building, where it was lifted atop the Space Launch System. And that actually capped the assembly of this giant moon rocket, the first time a fully assembled, fully stacked Space Launch System was in the vehicle assembly building. So this rocket has been fully stacked now since last October, and is currently on its third visit to Launch Complex 39B this year, following two campaigns in April and June for wet dress rehearsals or practice countdowns, and then a rollout earlier, or actually last month, mid-August, to prepare for the Artemis 1 launch itself. The first launch attempt was 5 days ago on Monday. That was scrubbed a few hours before, with a few hours remaining in the countdown, after teams detected a few problems. One was a hydrogen leak. That was resolved during that countdown, but ultimately what caused the scrub Monday was an indication that one of the four engines on the bottom of the core stage was not reaching its proper cryogenic temperature. Those engines need to be thermally conditioned before they can safely ignite. They need to be conditioned down to cryogenic temperatures of around minus 420 degrees Fahrenheit, which is also the temperature of the liquid hydrogen fuel on board. Reviews of data from the launch attempt Monday over the course of the week convinced NASA officials that that data they were receiving, that the engine was not at the right temperature, came from a bad sensor. So the data appeared to be erroneous, and managers approved proceeding with today's launch attempt, and they will use other means, other indications, to confirm that those engines have indeed reached the proper temperature for ignition. There are different instruments, operational flight instrumentation associated with each engine that feed data to the onboard computer on the Space Launch System. And the system is designed to actually detect if those engines are not at the right pressures and right temperatures, and would automatically cut off the countdown in the final 30 seconds or so if it detects those engines are not properly thermally conditioned. We're continuing to watch these views from engineering cameras panning down the length or the height of the Space Launch System. We're now looking at the bottom of the liquid hydrogen tank where it connects to the core stage engine section. And now we're seeing one of the RS-25 engines there, bottom left, one of the four. And on the right, you can see the tail service mast umbilical area where the propellants are flowing into the vehicle. See the venting coming out of those engines as the propellant loading operation is proceeding this morning, albeit at a slower pace than expected. On the right is one of the aft skirts of one of the solid rocket boosters. You can see that nozzle there. These two boosters on either side of the core stage will supply more than 80% of the thrust for the rocket at liftoff. Those will burn for about 2 minutes and 12 seconds before jettisoning to fall into the Atlantic Ocean. They will not be recovered. The core stage will burn for 8 minutes. And then the upper stage, which is yet to be fueled this morning, will fire its single RL-10 engine 2 times, first to enter a stable low Earth orbit, and then to propel the Orion spacecraft to the moon for this Artemis 1 test flight. We're now seeing that gaseous oxygen venting out of the top of the core stage as the liquid oxygen loading is continuing at a good pace this morning. Liquid hydrogen moving a little slower as the team troubleshoots this indication of a hydrogen leak near the umbilical connection between the mobile launch platform and the bottom of the core stage. While we wait further word from NASA on this troubleshooting of this hydrogen leak, this view looking out to sea from one of the lightning towers at pad 39B shows the space launch system. You can see some hints of vapor from that gaseous oxygen vent at the top of the core stage as liquid oxygen loading continues onto the vehicle. Looking out to sea, there's the Atlantic coastline. Some scattered rain showers are just a few miles, maybe more than a few miles, but visible certainly offshore. None of those are approaching the launch pad area at this time, although there is a threat of that later this morning and in the early afternoon hours. Off to the right in this view, you're looking down the coast toward the south from pad 39B. If you look closely, you can see Launch Complex 39A, which is leased by SpaceX from NASA. You can see the Starship launch tower under construction there, along with a crane to facilitate that construction. And then you see the pre-existing fixed service structure at pad 39A that supports crew launches on the SpaceX Crew Dragon spacecraft and the Falcon 9 rocket. And then further in the distance is Space Launch Complex 41, operated by United Launch Alliance for the Atlas V rocket. Latest numbers on propellant loading status on the core stage. Liquid oxygen is at 54% full on the core stage. And liquid hydrogen is now at 7%. NASA's launch team reports this liquid hydrogen system leak is continuing. Data continues to show that there is a leak so far in this troubleshooting process. The team initially tried to warm up this quick disconnect fitting in an 8-inch line where the leak is believed to be originating. That does not appear to have worked. The leak is still evident in data. So the next step in the firing room will be for the launch team to increase pressure at an umbilical line using helium in hopes that this further step will reseat a seal in this quick disconnect fitting to resolve this leak. Right now the hydrogen loading is running about an hour behind schedule, at least, maybe a little bit more at this point. The core stage liquid hydrogen should have been in what is known as fast fill mode nearly an hour ago, and that has not happened and appears to be at least some period of time from beginning, even if the leak is resolved. Now less than 5.5 hours until the opening of today's launch window. The launch team for Artemis 1 here at the Kennedy Space Center continues to troubleshoot this leak in a liquid hydrogen system. It's in an umbilical connection between the bottom of the core stage and the launch platform area. Hydrogen leaks have been a pervasive issue for the Space Launch System during this year's countdown rehearsals and now into the launch campaign and launch attempts themselves. So the team is troubleshooting this in hopes of clearing this leak and resolving this leak and launching today, although the countdown is now running behind schedule. If you're just joining us and you haven't had a chance to yet, please like our stream here on YouTube. Please like our stream here on YouTube if you haven't already. This helps us expand the reach of our coverage and grow our audience, so we really appreciate that. We want to bring our coverage to as many people as we can. You can also join our YouTube channel if you haven't already. We have different membership channels available for you to choose from. And depending on which level you choose, you can gain access to exclusive bonus video features for members only here on our YouTube channel. You can also contribute through the Superchat function here on YouTube. And your contributions and support really helps us continue to bring you live coverage covering this Artemis 1 launch campaign. It involves a lot of long hours here at the Kennedy Space Center with these countdowns and rehearsals, rollouts, rollbacks. And of course, we're also covering the continued operations of SpaceX's Falcon 9 rocket here at Cape Canaveral and at the Kennedy Space Center. Another Falcon 9 launch with another batch of Starlink internet satellites is scheduled for Sunday evening. That's tomorrow night at 10:09 p.m. Eastern Time, 2:09 a.m. UTC Monday, from Space Launch Complex 40 down at Cape Canaveral Space Force Station, just a few miles down the road from Pad 39B here at the Kennedy Space Center, which you're looking at live right now as NASA counts down for today's launch attempt for the Artemis 1 test flight to send the Orion spacecraft around the moon and back to Earth. If the launch happens today, the Orion spacecraft will spend nearly 38 days, just shy of 38 days in space, returning for a splashdown after orbiting the moon in the Pacific Ocean on October the 11th. This schedule assumes this mission gets off the ground today. Camera view you're looking at now is on the west side of Pad 39B, looking toward the east. You can see some of the cloud cover just offshore behind the Space Launch System, which is silhouetted against the morning light. It's been at least a few minutes since we've got an official update on the status of this troubleshooting of this hydrogen leak from NASA's launch team. The launch team is stationed in Firing Room 1 of the Launch Control Center, right next to the Vehicle Assembly Building here at the Kennedy Space Center. The team is led by Launch Director Charlie Blackwell Thompson, and the launch team in Firing Room 1 consists of about 91 engineers and managers monitoring various systems on the Orion spacecraft, the Space Launch System and its various systems, various elements, such as the core stage, the engines, the upper stage, the boosters. And teams are also monitoring the performance of the ground systems out at Pad 39B. At liftoff, when the two solid rocket boosters ignite. Control of the mission will be handed over from the Launch Control Center here in Florida to the Mission Control Center at NASA's Johnson Space Center in Houston, where a flight control team led by Judd Freeling, the Ascent and Entry Flight Director for Artemis 1, will be tracking and controlling the flight throughout the rest of the climb to space. NASA says troubleshooting of this leak is continuing here at the Kennedy Space Center. Liquid oxygen is continuing to flow into the rocket at this time, into the core stage, now 66% full on that tank. Liquid hydrogen is still holding at around 8% full on the core stage. The team is applying pressure using helium to the umbilical line where the leak has been discovered in a quick disconnect fitting in the connection near the bottom of the core stage with the launch platform. That's the area of the tail service mast. Here you're seeing a view of the 4 RS-25 engines on the bottom of the core stage. The tail service mast is actually on the opposite side of the vehicle from this camera view. And there are plates, a ground side and a flight side umbilical plate that connect to one another. And the leak that has been detected this morning is in the cavity between those plates. A leak of gaseous hydrogen was detected. Elevated levels of gaseous hydrogen were detected in that area. There are hazardous gas sensors all around the launch pad to detect leaks such as this, and NASA has safety limits in place that would essentially halt the propellant loading process if concentrations of hazardous gases reach a certain threshold, and that's what happened earlier this morning. Very early in the loading process for liquid hydrogen is when this leak was detected. The liquid hydrogen is chilled to minus 423 degrees Fahrenheit. So it's a very cold fluid, cryogenic fluid. 537,000 gallons are to be loaded into the rocket to power or to fuel the core stage engines. So far, about 45,000 gallons of that capacity has actually been loaded into the vehicle. You're seeing now an up-close view from one of the engineering cameras at the pad showing this tail service mast umbilical area. You can see those plates, those square shapes that push up against the engine section of the core stage. On the right-hand side is the liquid hydrogen umbilical, and in that region, according to what we're hearing from NASA's launch team, is where the leak has been detected. These vapors you're seeing are normal. That's not associated with this leak. On the left side is a liquid oxygen umbilical. Again, this is at the base of the core stage where propellants flow from the ground storage tanks through lines in the mobile launch platform deck, through the tail service mast, and finally into the vehicle. This is used during propellant loading and draining operations on the pad. Liquid oxygen now at 69% full. Liquid hydrogen still holding at 8% full at this time as the team troubleshoots this leak by applying pressure into that umbilical line using helium. And the loading of liquid hydrogen does still appear to be in a stop flow status with apparently no hydrogen actually flowing into the vehicle at this time. NASA's launch team has completed this additional troubleshooting step that involved applying pressure to this umbilical line connection using helium. They applied pressure for a period of time and now are resuming. Now the launch team is resuming the flow of liquid hydrogen through this line, and the team will monitor the sensors in this area that are designed to detect any leak or hazardous gases to see if this additional troubleshooting step resolved this problem. Right now the countdown in terms of liquid hydrogen load is now running more than an hour behind schedule, at least an hour and 15 minutes behind schedule from a liquid hydrogen perspective. But liquid oxygen loading is continuing right on schedule at this time, now 71% full on the liquid oxygen side of the core stage. If you're just joining us, we're continuing to watch live views of Launch Complex 39B here at the Kennedy Space Center. NASA's launch team in the firing room at the Launch Control Center is continuing to troubleshoot a liquid or a leak in the liquid hydrogen loading system. This is in the connection area between the mobile launch platform and the core stage. Indications of this leak first cropped up about 2 hours ago, a little more than 2 hours ago. And the team has been troubleshooting it since then. The launch team has a 2-hour window to work with today. The window opens at 2:17 p.m. Eastern Time, 18:17 UTC, and runs until 4:17 p.m. Eastern, or 2017 UTC. We thank you for joining us for our coverage today, and we want to give a big shout out to Space Pony on YouTube for gifting 5 Spaceflight Now memberships to our audience. We really appreciate that support. If you're unable to grab one of those, we invite you to join our YouTube channel and become a member. You can gain access to exclusive video features, bonus materials, and you'll be supporting our coverage. It helps us bring coverage like this to you. NASA's launch team has resumed the flow of liquid hydrogen in a very slow manual mode into the core stage after completing this latest troubleshooting procedure by applying pressure to this leaky connection. This is a quick disconnect fitting in an 8-inch line that flows liquid hydrogen into the rocket. The initial troubleshooting step earlier this morning that involved warming up this connection to try to reseat the seal did not fully resolve the leak. So the next step was applying pressure using helium, and this team is now resuming flow to see if that secondary or additional troubleshooting step worked as intended. As we await an update from NASA on whether this latest troubleshooting procedure worked on the liquid hydrogen loading of the core stage, here's a look at what the propellant capacity is for the entire vehicle out on pad 39B. If the countdown continues through the rest of the day, the plan is to load 755,000 gallons of propellants into the Space Launch System. By far, the biggest tank by capacity, by volume, is this core stage liquid hydrogen tank, which is still less than 10% full right now. That tank will contain 537,000 gallons of liquid hydrogen chilled down to minus 423 degrees Fahrenheit when fully loaded. Liquid oxygen on the core stage continues flowing into the vehicle. It's a tank that will contain 196,000 gallons of oxidizer chilled down to about minus 298 degrees Fahrenheit or so. Once the launch team is getting in the late stages of loading the core stage, they will begin flowing propellants into the interim cryogenic propulsion stage. This is the upper stage of the Space Launch System, produced by United Launch Alliance based on ULA's Delta IV Heavy rocket upper stage. It's a much smaller stage, 17,000 gallons of hydrogen fuel, 5,000 gallons of liquid oxygen oxidizer will go into that stage later into the countdown. So 755,000 gallons in total will be loaded into the vehicle before the launch of the Artemis 1 test flight around the moon. Fully fueled, the Space Launch System will weigh about 5.75 million pounds at the time of liftoff, and that mass will be propelled off the launch pad with 8.8 million pounds of thrust from the 2 solid rocket boosters and the 4 core stage engines. The rocket will accelerate from 0 to 107 miles an hour in about 7 seconds as it clears the mobile launcher tower. Ultimately, once the core stage, the solid rocket boosters, and the ICPS upper stage have all done their job, the Orion spacecraft will be traveling at a velocity of about 22,500 miles per hour relative to Earth on a translunar trajectory toward the moon. Here's a graphic from, well, that was a graphic from NASA from their feed showing the status of loading propellants. Liquid hydrogen now at 9% as the liquid hydrogen tank is being slowly filled right now. Very, very slow flow rate going into the hydrogen tank as the team monitors for this leak. Liquid oxygen on the core stage now at 80%. This view from an engineering camera, camera 917 out at pad 39B, an up-close view, showing an up-close view of the foam insulation on part of the core stage. You can see those vapors coming from the rocket here as super cold liquid oxygen continues flowing at a good rate into the the core stage of the Artemis 1 vehicle. The foam insulation is a spray-on thermal insulator that's applied to the core stage as well as the launch vehicle stage adapter just above it. The insulation is similar to the foam insulation that was used on the space shuttle external tank, that orange, iconic orange color to that external tank. A similar foam is applied to the core stage of the Space Launch System, although it has been updated. The formula has been slightly updated to comply with modern environmental standards. The foam is designed to do a couple of things. One is to reduce the buildup of ice on the outer skin of the rocket as this cryogenic fluid is loaded into the vehicle during tanking, and it's also designed to help insulate the tanks to minimize boil-off of the cryogenic propellants during the countdown. NASA's launch team reports that this second troubleshooting plan apparently did not resolve this hydrogen leak. Sensors continue to detect indications of a leak that exceed the 4% safety threshold out at the pad. So this 8-inch, this connector and this 8-inch line continues to show signs of a hydrogen leak. The launch team is now discussing further steps, additional troubleshooting that they may pursue this morning to try to resolve this leak. Right now the liquid hydrogen loading into the core stage is running more than an hour and a half behind schedule. There is a little bit of flexibility in the countdown timeline, although it's not clear that the team can make up all of this time. There is a 2-hour window also available this afternoon for today's launch opportunity from 2:17 p.m. Eastern Time to 4:17 p.m. Eastern Time. That is 18:17 to 20:17 UTC. Here you see the countdown clock at the press site here at the Kennedy Space Center continuing to tick down. T-minus 4 hours, 12 minutes, 16 seconds at this time. The countdown is heading toward the next pre-planned hold at T-minus 10 minutes. That hold is slated to last 30 minutes, so therefore we're now 4 hours, 42 minutes from the start of today's launch window. Here's the status of the fueling operation this morning. The liquid oxygen on the core stage at 86% full. Liquid hydrogen on the core stage now at 10%. The liquid hydrogen system is the one that's exhibiting signs of a leak in the connector near an umbilical plates rather, where the tail service mast connects to the bottom of the core stage in the engine section area. There are 2 umbilical plates there, a ground side plate that remains with the mobile launch platform at liftoff, and a flight side plate on the rocket itself. And according to what we've heard from NASA's launch commentator, the signs of a leak have been in the cavity or the area between those 2 umbilical plates. And engineers believe that the leak is in a quick disconnect fitting in an 8-inch liquid hydrogen line. Again, the liquid hydrogen tank still holding at about 10% full. It hasn't moved much over the last couple of hours. It's been hovering between 5 and 10% as the team toggles on and off between filling the liquid hydrogen tank and then troubleshooting and then trying to flow propellants once again to see if the troubleshooting fixed the leak. Each time they've done that so far, the leak is still there. So they can't progress into what is called fast fill mode, which is when hydrogen is allowed to more rapidly go into the tank on the core stage until this leak is stable and below this 4% safety threshold that has been exceeded with this leak. NASA's launch team has discussed several options and how to proceed with the countdown this morning, and the plan is to go back to what they're calling Plan A, to go back to the original troubleshooting attempt that they made a couple of hours ago, which involves allowing the Leaky quick disconnect fitting to warm up from its cryogenic temperature to warmer temperatures. That will hopefully allow that fitting to relax a bit at warmer temperatures, and then they'll try to flow this super cold propellant liquid hydrogen back through that line, which will essentially cause that component to change shape and contract. And NASA engineers have experience with this troubleshooting procedure, helping resolve leaks during cryogenic loading operations. They have experience seeing this type of troubleshooting actually end up reseating leaky connections and seals. It did not work earlier this morning when they tried it the first time, so they moved on to other options. Another option, which was applying pressure, which also didn't work, also didn't cause this leak to disappear. So they're going to go back to Plan A, which they have a lot of experience with. They've seen this work before. Didn't work this morning when they tried it earlier, but they're going to try again to see if it resolves this leak this time. The liquid hydrogen loading is now more than 2 hours behind schedule. We're not sure exactly how much flexibility NASA has in their countdown timeline this morning, but it is worth noting there is a 2-hour window, and the liquid hydrogen loading is more than 2 hours behind schedule at this point. The liquid hydrogen tank should now be in fast fill mode. It should have been in fast fill mode now more than 2 hours ago, and it's not in fast fill. In fact, it's not even in slow fill. According to NASA's launch team, the flow is stopped now to allow this quick disconnect fitting to warm up a bit. Meanwhile, on the liquid oxygen tank at the top of the core stage, that tank is now in topping mode. So liquid oxygen is nearing the end of its loading procedure onto the core stage at this time. This view of the Space Launch System comes from a camera at the press site here at NASA's Kennedy Space Center, 3.5 miles away from the pad. The vapors from the gaseous oxygen vent at the top of the core stage, very apparent this morning, that white cloud of vapor coming from the boil off of oxygen, liquid oxygen, on that core stage tank. So the liquid oxygen tank is full, or nearly full at this point. That loading has gone well this morning, but liquid hydrogen remains an issue, a holdup in the countdown. That loading of liquid hydrogen is now more than 2 hours behind the timeline on the core stage. NASA is continuing to troubleshoot this hydrogen leak that's causing this delay in the hydrogen loading. And the latest plan we've heard is they're going to allow this quick disconnect fitting in the tail service mast umbilical area, near the umbilical plate that connects to the core stage, which actually you see here on the right of your screen. That's the liquid hydrogen umbilical plate. There's a leak somewhere in that vicinity, and a quick disconnect fitting, and they're allowing that to warm up. They hope that will relax that component, and then they'll flush or flow liquid hydrogen back through the line, which will kind of reshape, allow that connector to contract as it's exposed to cryogenic temps, and then NASA hopes that will close up that leak. This troubleshooting procedure was already tried this morning. It did not work, but it has worked in the past, so they're going to give it another shot. This view from one of NASA's engineering cameras at Launch Complex 39B shows the intertank umbilical connected to the intertank section between the hydrogen and oxygen tanks on the core stage. See both of the solar rocket boosters there, and in the distance off to the right, nearly 4 miles away, is the vehicle assembly building where this rocket was stacked in High Bay 3 over the course of the last almost 2 years now. The solar rocket boosters began stacking in late 2020 onto the mobile launch platform deck. The core stage was added in June 2021, about 15 months ago. That was followed by the upper stage and the Orion spacecraft, which was installed last October. Weather conditions here at the Kennedy Space Center continue to look fairly favorable today. Fair skies, some scattered clouds, some showers lurking offshore over the Atlantic Ocean, but none of those show any signs of imminent impact to the spaceport this morning. So the main issue of note is this hydrogen leak, which is still undergoing troubleshooting. This graphic from NASA shows the status of the propellant loading onto the core stage right now. Liquid hydrogen is at 10%. It's now at 52,500 gallons or so. We've seen that very slightly increase over the last couple of minutes. It was at 9%. Now it's at 10%. So right now the launch team is manually controlling the flow of liquid hydrogen through the tail service mast umbilical into the tank on the core stage of the Space Launch System. This shot is a little bit blown out, but on the right side is the tail service mast umbilical connection for liquid hydrogen. On the left is liquid oxygen. So on the right side, there's a plate. You might be able to make out the square, that the white square that goes up against the engine section just to the right of that checkerboard pattern. That's the ground side connection between the umbilical plates on the ground side and the flight side. And the leak has been detected in that area. The launch team has pursued several troubleshooting options this morning. They allowed the umbilical connector to warm up to ambient temperature a few hours ago to try to get that connection to relax, and then they reapplied propellant, super cold propellant through that line to try to get the seal to reseat itself. That didn't work, so then they applied pressure through that line with helium to try to get the same result. That also did not resolve the leak. And now NASA says they've gone back to plan A, which was the warming of that connector. And they've allowed it to warm up once again this morning, and are now flowing propellants through the line to see if they can still detect any signature of a leak there. This is in the tail service mast umbilical. On the hydrogen side, we've circled that area here. That's where the mobile launch platform deck connects to the bottom of the core stage at the engine section area. Here's a photo taken during one of the rollbacks of the Space Launch System earlier this year, with a view of that tail service mast umbilical where it connects to the engine section. The lines you see here on the side in the foreground, on the camera side of this view, is the hydrogen line. We just heard from NASA's launch team that the latest troubleshooting step of allowing the connector to warm up and hope to reseat that seal did not work. Liquid hydrogen is still leaking. NASA's launch team said that they resumed the flow of liquid hydrogen, and when they applied pressure to that line, they saw the leak return. So 3 troubleshooting attempts now have been attempted, and the leak is still present. And the launch team is discussing their next steps this morning, and we'll stand by for an update from NASA on whether they're going to continue with this countdown this morning. It's now been about 10 minutes since our last update from NASA's launch team on the progress of this morning's countdown. That's been slowed by this hydrogen leak. Here's an up-close view from a NASA engineering camera out at pad 39B showing the tail service mast umbilical connections to the core stage of the Space Launch System moon rocket. On the right side is the hydrogen connection. That's where this leak is located. It's in that connection with the core stage. There are two plates, a ground side umbilical plate that stays with the launch platform at liftoff and a flight side umbilical plate that remains on the rocket. What we've heard earlier this morning is the sensors, hazardous sensors, HazGas sensors at the pad have detected gaseous hydrogen in the cavity between those two plates, and that was the first sign of a leak this morning during the hydrogen loading process. Very early, in the early stages of this hydrogen loading process, is when the leak cropped up. There have now been 3 attempts to troubleshoot this leak, twice by allowing this connection to warm up, once by applying pressure with helium through this system to try to get a seal to reseat itself. None of those have worked. And the latest update we've heard from NASA is that the launch team is discussing their path forward this morning. The hydrogen loading timeline is now approaching 2 hours, 45 minutes behind the timeline going into today's countdown. And of course, the duration of the launch window is 2 hours. There is a little bit of flexibility in the schedule and the countdown to make up some time, but they're now 2 hours and 45 minutes behind the expected timeline. That's 45 minutes longer than the duration of the launch window. So it may be nearing a time for the launch director to make some decisions on whether to proceed this morning, maybe attempt one more troubleshooting attempt, or they may decide to scrub the launch attempt this morning. We have no official word yet on which path the team will take. We'll stand by for word from NASA and news on the progress and status of today's launch attempt. We've been cycling between different camera views out at pad 39B. You'll notice on some of these there are numbers on the upper right of the frame in some of these views. The numbers, you can tell where the camera is located by the 9 or 8. In this case, you're looking at camera number 917. And if the number begins with 9, it's a camera that's permanently positioned out at pad 39B. Around the launch complex. And here's camera 808. The cameras that start with the number 8 are on the mobile launch platform itself on which the Space Launch System rocket is sitting. Here's camera 815 showing one of the umbilicals. This is the inner tank umbilical, I believe, connecting to the core stage. This connects to the area between the hydrogen tank down below and the liquid oxygen tank above this level on the core stage. You can see the vehicle assembly building more than 3.5 miles away in the distance, and the flat building, the low-rise building just to the left of the vehicle assembly building is actually the Launch Control Center. That's where the launch team is stationed this morning in firing room 1. NASA is not providing any camera views inside of the firing room at this point in the countdown. Despite requests from us, we would love to see what the launch team is doing in the control center as they work through these issues. But NASA is not providing those views to the news media today. Here's a camera 907. Again, number 9 designates that it's a pad camera out at Launch Complex 39B. This is on the west side of the rocket looking east. NASA's launch team has presented a recommendation of being no-go for today's launch attempt for the Artemis 1 mission. We're awaiting a final decision from the launch director, Charlie Blackwell Thompson, on what seems to be a likely scrub for this morning. We're standing by for that official confirmation. NASA's Artemis 1 launch director Charlie Blackwell Thompson has received this recommendation from the launch team a few minutes ago that they're no-go for proceeding with today's launch attempt. She is currently discussing with the team options for their path forward before officially declaring a scrub today, but all signs point to no launch today for the Artemis 1 mission. We're just awaiting that final official confirmation to make that a formal declaration from the launch director, Charlie Blackwell Thompson. It's possible that the launch team could, knowing that there will be no launch today, the team could proceed into further troubleshooting and tests to gather data on this hydrogen leak. That data could help pinpoint the location of the leak and give the team options of how to resolve it before the next launch attempt. So we're going to stand by for further news from NASA. The Artemis 1 launch team is working inside firing room 1. That's also known as the Young Crippen firing room, named for the astronauts John Young and Bob Crippen, who flew on the first space shuttle mission back in 1981. In this view from one of the cameras on the mobile launch tower at Pad 39B, you can see the vehicle assembly building in the background under some partly cloudy skies here on Florida Space Coast. Next to the vehicle assembly building to the left, you can see a kind of a flat, low-rise structure. That is the Launch Control Center. And there are 91 engineers working inside the firing room 1 of the Launch Control Center this morning. 91 engineers on the Artemis 1 launch team. There are additional support engineers inside firing room 2 of the LCC, and there are support teams elsewhere here at the Kennedy Space Center. Also teams at the Johnson Space Center in Houston, where Mission Control is located, that they will take control of the flight after liftoff. And there are also engineers at the Marshall Space Flight Center in Alabama monitoring the countdown. That's where the Space Launch System program is headquartered. And United Launch Alliance has teams also tracking the countdown. ULA provided the upper stage of the Space Launch System. So we're just standing by for this confirmation of an official scrub declaration for this morning's countdown. Again, all signs point to no launch today for the Artemis 1 mission. NASA's Artemis 1 launch director, Charlie Blackwell Thompson, has officially declared a scrub. So the launch of the Artemis 1 mission, as expected, is not going to occur today. You can see the countdown clock on the upper right is now holding at T-minus 2 hours, 28 minutes, and 53 seconds. So this was the official time of the hold, the scrub. So the countdown is now being cut off, and the next step will be to configure for the draining of propellants from the core stage. Liquid oxygen was fully loaded onto the core stage during this morning's countdown, so they'll have to remove that from the vehicle. No word yet on a next launch attempt. If you're just joining us, a couple of minutes ago, NASA confirmed that the launch attempt today has been scrubbed. So the Artemis 1 mission is not taking off today. There was a persistent hydrogen leak near an umbilical connection between the mobile launch platform and the core stage. Multiple attempts to resolve that leak through troubleshooting were unsuccessful. There's no word yet on when NASA could make another launch attempt. They have Monday and Tuesday as opportunities in this launch period when the position of the moon and Earth are in the proper location relative to one another to make this mission possible. But we'll see how long it's going to take for NASA to address this hydrogen leak issue. Hydrogen leaks have been a recurring problem during the Artemis 1 launch campaign, both in countdown rehearsals as well as the 2 launch attempts so far. As you're watching this view of the Space Launch System on the launch pad, you'll notice there's no rotating or mobile gantry around the vehicle, so there are limited, the access to different parts of the vehicle is rather limited for technicians while it's on the pad. So any invasive or extensive work to repair a leak may have to occur inside the vehicle assembly building. And the other factor that's on the minds of the launch team right now is the certification of the rocket's flight termination system. The batteries for that system are certified through this launch period. That's already an extension that was granted by the range safety officials from the Space Force's range team here at Cape Canaveral. NASA did get an extension for that from the Space Force up through this launch period. But if they don't get off the ground by September the 6th, which is Tuesday, they'll have to roll back to the vehicle assembly building anyway to retest that flight termination system and recertify it for another series of launch attempts. And given the time to do that, it's not likely. NASA officials have said that the rocket will be ready during the next launch period, which opens on September the 19th and runs through October the 4th. Certainly, if they have to roll back, they won't be ready on September the 19th. So if they don't launch Monday or Tuesday, the mission would face a likely delay to sometime in October, perhaps. So the next launch periods are September the 19th through October the 4th, and then the following period opens up on October the 17th. These cycles are roughly 2 weeks on, 2 weeks off, to allow the Orion spacecraft to fly its mission around the moon and return to Earth and meet all of its flight rules and safety criteria. There are other factors at play, such as the Orion solar arrays cannot be in shadow for more than 90 minutes during the entire flight to ensure that the vehicle has enough electricity. NASA also wants the splashdown of the Orion spacecraft at the end of the mission to occur in daylight in the Pacific Ocean, so they have to take that into account. And there's just the performance of the Space Launch System and the Orion propulsion system to power the vehicle to orbit the moon and return to Earth, and make sure there are enough propellant margins for that. So they have to take in all these factors into account when setting these launch periods. And it filters out to roughly 2 weeks of launch availability, followed by 2 weeks of time when the launch is not possible. So NASA managers will have to make some decisions in the coming hours or day or so to decide whether to proceed with another launch attempt Monday, if they think they can fix this leak by then. They also have Tuesday as a backup opportunity. However, Tuesday's launch window is only 24 minutes in duration. The launch attempts so far have had 2-hour launch windows to work problems such as leaks. The launch window Monday is 90 minutes, and on Tuesday it's only 24 minutes. We expect to hear from NASA, a member of NASA's launch team, shortly for some context and details on what happened this morning and what they might be considering as options going forward. Once again, to recap, you're looking live at NASA's Space Launch System moon rocket on Launch Complex 39B at the Kennedy Space Center in Florida. Today's launch attempt has been scrubbed. The Artemis 1 mission will not get off the ground today after the team encountered a hydrogen leak that was persistent and was not able to be resolved. Several attempts to troubleshoot and fix the problem remotely using temperature gradients and pressure to try to reseat a seal and a quick disconnect connector were unsuccessful. So NASA's launch director Charlie Blackwell-Thompson has officially declared a scrub, and she and other managers from NASA, including the Artemis 1 mission manager Mike Serafin, are discussing their options for the path forward. There are 2 more launch opportunities available in this launch period on Monday and Tuesday, but that assumes the leak that caused today's scrub is fixed by then, and that's not a slam dunk given the nature of hydrogen leaks and the limited access to the vehicle out at the pad. This leak is in the fill and drain system for liquid hydrogen, so the launch team was able to load about 11% of the liquid hydrogen tank during today's countdown through this tail service mast umbilical connector. And the team will have to be cognizant of that leak as they drain the little bit of liquid hydrogen. I say a little bit, it's I think more than 40,000 gallons of liquid hydrogen that was loaded into the vehicle this morning. They'll have to be cognizant of that leak as they drain that fuel. Again, we expect to hear from a member of the Artemis 1 launch team shortly. NASA is going to provide that video to us, and we'll take that video live when we get it. So we'll pass on to that when we have that interview underway. We'll stand by for that. If you're just joining our stream, the Artemis 1 launch attempt today has been scrubbed due to a persistent hydrogen leak that was found in the very early stages of hydrogen loading onto the core stage. This leak is down around the tail service mast area. In that connection between the tail service mast and the core stage. We're seeing views now from engineering cameras out at the pad showing the core stage. Here you can see the liquid oxygen feed line venting. Some vapors actually appearing as the cold fluid liquid oxygen flows through that line as they drain the liquid oxygen tank on the core stage. That liquid oxygen tank was fully loaded during the countdown per the plan this morning, while the liquid hydrogen tank only reached the 11% full point. So the team is now draining propellants. First liquid oxygen, then liquid oxygen. Sorry. First liquid oxygen, then liquid hydrogen from the core stage as they back out of today's launch attempt and out of today's countdown. We're awaiting an interview that NASA Public Affairs will be conducting with a member of the Artemis team at the Launch Control Center. We hope that interview will provide some insight and context on what happened this morning and the options or decisions that NASA is considering or has made for the path forward for the Artemis 1 launch campaign. As I've mentioned, the options are essentially to try to fix this leak and perhaps proceed with a launch opportunity Monday or Tuesday. Those are the last two launch dates available in this launch period. Or they may have to roll the vehicle back to the vehicle assembly building for repairs of this leak and also to retest and recertify the flight termination system. Hello again from the Kennedy Space Center. We're still waiting on a post-scrub interview from NASA. That's going to be aired on NASA TV. We'll bring that to you on our stream here on our YouTube channel live when we see it, when we get it. The interview will be with the NASA Administrator Bill Nelson, who will discuss today's launch attempt and may offer some of NASA's thinking for the next step for the Artemis 1 launch campaign. As I mentioned, managers will have to decide soon whether they think they can make another launch attempt Monday or Tuesday. If they are unable to, because of this leak, they will have to roll back to the vehicle assembly building for recertification and retesting of the flight termination system, and perhaps to do some hands-on work in this tail service mast umbilical plate area where it connects to the core stage to resolve the leak that cropped up today. If that happens, launch likely will be pushed back to sometime in October. Again, the launch periods run on cycles for this mission of about 2 weeks on, 2 weeks off. So this launch period, which is officially known as launch period 25, closes on Tuesday. Tuesday is the last date in this launch period. Launch period 26 opens September the 19th, runs through October the 4th. But if you take into account the time it takes to basically prepare the rocket to return to the VAB, return it to the vehicle assembly building, do the work required in the assembly building, and then roll back out to the pad, the next launch period may not be available just for the amount of time it takes to do all that work. So the following launch period 27, opens up on October the 17th. And now we're expecting to hear from NASA
Artemis
Administrator
1 mission, space
Bill
launch
Nelson
system and Orion spacecraft.
momentarily. And here
Good
is
to have you back,
NASA
Administrator.
TV's commentator Daryl
Unfortunately,
Nail with the
not
NASA
the result we were
Administrator
looking
Bill
for
Nelson.
today either. Want to get your thoughts and your reaction.
We'll go when it's ready. We don't go until then, and especially now on a test flight, because we're going to stress this and test it and test that heat shield and make sure it's right before we put 4 humans up on the top of it. So this is part of the space business. I've told you before, you know, it's something I'm accustomed to. On my flight, which was Hoot Gibson and Charlie Bolden's flight way back. It's something I'm accustomed to. On my flight, which was Hoot Gibson and Charlie Bolden's flight way back, we scrubbed 4 times. We were delayed over the better part of a month, but the 5th try was an almost flawless 6-day mission. So this is part of our space program. Be ready for the scrubs.
Space is hard indeed. The question now on everybody's mind is going to be, when will we have another launch attempt? Any thoughts on that?
Well, the mission management team is meeting this afternoon. They're going to look at it. They're going to see, is there still a possibility now, or are they going to have to roll back into the vehicle assembly building? If they decide that's the case, then it'll be an October launch. And October, I would say, although the window opens in early, I suspect it'll be more like the middle. Because remember, the first week of October, we've got another crew. It's an international crew, 2 international participants on the crew of 4 that are going to the International Space Station.
That's right. SpaceX's Crew 5, NASA and SpaceX's Crew 5 mission scheduled for early October. You mentioned the MMT, of course, the mission management team. They're going to meet this afternoon, and then hopefully we'll have a press conference after that. I've been watching this launch team for the past 2 weeks now, and just impressed at how focused and how hard they work. Any thoughts you want to share with them about the effort they put in so far?
I'm very proud of the launch team. They do it right. They do it by the book. They do it very professionally. And that's why we have had this extraordinary success that we've had over the years. Sometimes we make mistakes, but we try to minimize those because these are human being lives on the top of that rocket. And I can tell you, when you strap into that rocket, you are very grateful that you've got a launch team like this that knows what they're doing, and they're not going to let you go until it's time.
And you know firsthand the power of those RS-25s and those 2 solid rocket boosters from your flight. Really quickly, before we let you go, you were over there at our VIP area as well. Had some special guests. You were telling me an interesting story about a guest you had there.
There was a young man before he was 7 years old. He wanted very much to be an astronomer. And he signed a document with other children that is on Artemis. And the reason that's so important, that young man named Gaskin died from brain cancer. His family is a special guest of NASA here today. Today he would have been 13 years old. And so we particularly recognize the family in front of all of our international and American guests today.
What an honor for that family to have them there. All right, that'll do it for us. Thank you, Administrator Bill Nelson. Appreciate you being here. Unfortunately, we didn't get a launch today, but the hope is we're going to keep staying with it and see what happens next. That's going to wrap up our launch coverage on NASA TV.
That was NASA Administrator Bill Nelson speaking to NASA TV commentator Daryl Nail over at the Launch Control Center, in the adjacent to the firing room of the Launch Control Center, where the launch team is continuing with detanking operations. They're draining propellants from the Space Launch System as we speak out at Launch Complex 39B after today's scrub. You heard NASA Administrator Bill Nelson say that the team will go when they're ready. The launch will proceed when all parameters are acceptable. And the mission management team will meet this afternoon to discuss the plan forward, whether to try to proceed with another launch attempt either Monday or Tuesday, the last 2 days in this launch period, or roll the vehicle back to the hangar, the vehicle assembly building at the Kennedy Space Center for repairs. If the launch doesn't happen by Tuesday, the leak that we're talking about, the hydrogen leak notwithstanding, if the launch didn't happen by Tuesday, the rocket would have to return to the VAB anyway for recertification of the flat termination system. The certification clock for that system expires next week. So with the time needed to roll the vehicle back to the VAB, if that happens, the launch would be delayed until October. According to NASA Administrator Bill Nelson, that agrees with what we've heard from NASA officials prior to today. So the next launch period, when the Moon and Earth are in proper alignment for this mission to proceed as planned, opens September the 19th, closes October the 4th. But it's more likely, according to NASA Administrator Bill Nelson, that if the rocket has to roll back to the vehicle assembly building, the team would target the following launch period, which actually opens on October the 17th. Again, these launch periods are roughly on 2 weeks on, 2 weeks off cycles as the Moon orbits the Earth every 28 days or so. So we'll await news later today, hopefully, on whether the mission management team decides to make another go for it Monday or Tuesday, or to call off this series of launch attempts, roll the vehicle back to the vehicle assembly building, and reschedule this launch for October. While we wait for the next launch opportunity for the Artemis 1 mission, you can go to our Spaceflight Now store at shop.spaceflightnow.com. There we have mission patches for sale and other items as well for you to look at. Here we have the Artemis program patch, the Artemis 1 mission patch, and a commemorative Artemis patch related to this particular mission that are on sale on our Spaceflight Now store at shop.spaceflightnow.com. So if you want to go there and check that out, that would be great. Help support our coverage with any purchases you make there. Also, if you haven't yet, please like this stream to help us gain an audience for our coverage. You can also join our YouTube channel. We have different tiers of membership for you to choose from. And depending on which level you choose, you can gain access to exclusive bonus video features for members only on YouTube. Also, please subscribe to our channel if you haven't already done that as well. You'll get alerts when we're beginning a stream of launch coverage or other activity that we're covering here at the Kennedy Space Center and at Cape Canaveral Space Force Station. So again, to recap, the launch was scrubbed today due to a persistent hydrogen leak that troubleshooting attempts were unable to resolve. And there's no update from NASA yet on when the next launch opportunity might be scheduled. However, the mission management team will meet this afternoon to discuss their options, which range from perhaps attempting another countdown as soon as Monday or Tuesday. But if the launch doesn't happen Monday or Tuesday, the only other alternative is to actually roll the Space Launch System moon rocket back to the vehicle assembly building for repairs and retesting of the flight termination system before it is certified for another series of launch attempts. That would push the launch into October. We expect a NASA press conference later this afternoon as well following that mission management team meeting. We'll have that live on our YouTube channel. We're going to be ending this stream in a few moments, and we'll have another stream up on YouTube in a few minutes to show continuous live views of the Artemis 1 vehicle out on Launch Complex 39B until we await a decision on the next launch attempt. So we'll be streaming the press conference this afternoon on that new stream, so please check out our YouTube channel in a few minutes when that stream is active. We'll also have continuing coverage on our website at spaceflightnow.com and on our social media channels as well. So thanks for joining us today for this Artemis 1 countdown coverage. I'm Stephen Clark from spaceflightnow.com reporting live from the Kennedy Space Center. We'll see you next time.